Hi guys, welcome to the next video. Today I have a question for you which is based on the essentials of logic. If you have done my pre-calculus videos, there are some videos which are talking about mathematical logic, the symbolic logic. And today the question is based on that. In each of the following implications, x, y, z, they are numbers. You have to decide if the implication is true. And you also have to decide whether the converse is true. Now, do you remember? I'll just give you a brief brush up here. Do you remember an implication looks like P implies Q, where P and Q are two propositions, okay? Two statements that you propose. P implies Q means if P occurs, then Q occurs, which basically means that Q is necessary for the existence of P and P is sufficient for the existence of Q. When we say that the implication is true, there are certain conditions when the implications are true. In fact, an implication is always true, except for one place, where your hypothesis, that is P occurs, but the result that you're expecting is not the same. So Q fails. P happens, but Q does not happen. That's the only scenario where an implication fails. Or in other words, P does not imply Q. On the other hand, there's something called the converse. Now, what is converse? Converse of any implication is moving the other way around. In every theorem that you generally do, it's always asked, is the converse true? So theorems are generally, statements which are always holding true under certain assumptions. So if something happens, then some result will always hold true, and that becomes your theorem. There is a logic behind it. Then they always ask you, is the converse true? Which basically means, will Q also imply P or not? That's the question that we'll be answering for the questions that I've given to you. Okay, the first implication. X is equal to square root of 4 implies X is equal to 2. So is that true? So, well, this way implication is absolutely true, because in case X is equal to square root of 4, that automatically tells you that X is equal to the absolute value of 2, or it is 2. In other words, whatever comes out of a square root is positive, so it is 2. Absolutely, yes, right? What about the other way around? So basically, in case if X is equal to 2, then does that imply that X is equal to square root of 4? Is that true? Absolutely, yes. So this is true. And in fact, this is also true, because in case X is equal to 2, I can write X is equal to square root of 4, because square root of 4 will give me 2 only. So both ways it is correct. And now, a quick recap. In case P implies Q and Q also implies P, that means it's an equivalent statement, or we call it if and only if statement. That is, P is necessary as well as sufficient for Q, and so is Q. The second statement, X is equal to 2 and Y equals to 5. That implies X plus Y equals to 7. Indeed, if I put X, let's take this as given X is equal to 2, Y equals to 5. We want to prove X plus Y is 7. Well, what will we do? We will put the value of X as 2 and put the value of Y as 5. And indeed, we are getting 7, right? So this way implication is true. Now, by the way, when I was trying to solve this, what am I using? I'm using a proof strategy. I'm using the proof strategy of proving P implies Q. So I am assuming P and I'm trying to prove Q, right? In the previous question, I did that directly, but now I did it formally. Now, what we need to check is the other way around. The other way around is X plus Y equals to 7. Does that imply x equals to 2 and y equals to 5 simultaneously? Well, so for this one, what I'm going to do is I'm going to take as given x plus y is equal to 7. And I want to prove x is equal to 2 and y equals to 5. Is it possible? Well, the fact that x plus y is equal to 7 implies x is equal to 7 minus y. Y can take any value. X will be 7 minus y. So that means there could be many other values of x and y that gives you x plus y equals to 7. In fact, infinitely many solutions are there. So we cannot fix that x will always be equal to 2 and y will always be equal to 5 because that's a unique solution if you understand that language of solving equations. So you have one equation in two variables which will give you infinitely many results. And what you were supposed to prove is this unique solution. But no, that's one of the solutions, but it is not necessary that that will be the case. Okay. So we can say that this way, it is not true. This is false. This way implication is false. If x plus y is equal to 7, that does not imply necessarily that x equals to 2 and y equals to 5. I give you another way of thinking in it. So in P implies Q. Q is necessary, right? So here is Q necessary. Is it necessary that x has to be equal to 2 and y has to be equal to 5? Absolutely not. Even when x is not equal to 2, or even when I take the negation of, this, okay? So this would mean you have x is not equal to 2 or y is not equal to 5. If x is not equal to 2 or y is not equal to 5, can you get x plus y equals to 7? Well, yes, I can. What if, just take a case. What if, let's take a case that x is equal to 1, okay, and y is equal to, say, 6. Then also x plus y is equal to 7. So what are you getting? What you are getting here is, this is your P. This is your P part and this is your Q part. Okay. So if Q is not happening, that is not implying that P will not happen. P is still happening. So that means Q is not necessary for P here. By the way, your PQ was this here. Okay. It was a converse statement that we were looking at. So I'm talking about the converse. The converse doesn't hold true. Okay. So your original statement is true. And let me just write it up here. This is true. But converse is false. Because many other combinations of x and y can also be generated. Next question is, the product of x minus 1, x minus 2, x minus 3 equals to 0. That implies x is equal to 1. What do you think? Is this implication correct? If you start with x minus 1 into x minus 2 into x minus 3 is equal to 0, okay? You will get that x could be 1 or x could be 2 or x could be 3, okay? What our right-hand side is just x equal to 1. In other words, again, if I talk about necessary, is x equal to 1 a necessary condition for this product to be equal to 0? No, it's not necessary. Because even when x is not equal to 1, say it's 2. Then also, x minus 1 into x minus 2 into x minus 3 will be equal to 0. What I'm trying to say is that x equal to 1 is not necessary. You'd remember P implies Q. Q is necessary. P is sufficient. I just proved that Q is not necessary. That means this is not an implication which is true. So clearly this way it is false. What about the other way around? Is the converse true? Well, let's see. The converse says x is equal to 1 should imply x minus 1 into x minus 2 into x minus 3 equals to 0. Well, yes, the moment I will take x equal to 1, it is sufficient for this condition. X equal to 1 is sufficient for x minus 1 into x minus 2 into x minus 3 to be equal to 0. So, well, yes, the converse is true. So, this way it is false and the converse way it is true actually. Okay, so this is true. Let's look at the next case. X squared plus y squared equals to 0 implies x equals to 0 or y equals to 0. Well, is this implication true? So let x square plus y square be equal to 0. And we have to prove x equals to 0 or y equals to 0. In mathematics and in logic, we already know that or both is already included here. And well, guess what? What's happening here? If x squared plus y squared equals to 0, that automatically tells you that x equals to y equals to 0. Both actually have to be 0. So it's actually both of them being 0, right? So your condition gets satisfied. Your condition gets satisfied. X squared plus y squared equals to 0 is actually getting you that x is 0 and actually y at the same time is 0. So or both is included here. And that's why this is true. So this is a true implication. We will look into the other way around. So the other way around would be x equals to 0 or y equals to 0. Implies x square plus y square equals to 0. Well, now what are we saying? We are saying either x is equal to 0 or y is equal to 0 or both of them are 0. That implies x square plus y square is equal to 0. Now in your precondition, basically you are saying either or both. Had it been and, then it was correct. But since we have a scenario there where we are saying that, okay, just x equals to 0. Maybe y is something else. Y is some a. Then x square plus y square will be equal to a square and not 0, right? So which means the other way around is not correct. Implication this way is true, but the converse is false. Because in converse, we are saying either x is 0 or y is 0 or both. But that's just or condition, okay? Since it's our precondition, then x square plus y square cannot be equal to 0 in case only one of them is 0. What if we are taking the case that just one of them might be 0? What if just one of them is 0? Then your condition will not be met. Next one. Now that problem gets solved in E part. X equal to 0 and y equal to 0 implies x square plus y square equals to 0. Absolutely, if I take this way. So I assume that x is equal to 0 and y is equal to 0. Automatically, therefore, x square plus y square will be equal to 0, right? On the other hand, if you assume that x square plus y square equals to 0, that implies x is equal to y equals to 0. So x and y are 0. So that means here both the conditions are actually true. Both the implications are true. This is also true and the other way around is also true. X into y equals to y into z. That implies y equals to z. Well, yes, you take any three numbers x, y, z. This will always happen. X, y. So let's do this way. So given or assuming that xy equals to xz. Are we getting the right answer? So xy into xz. At the first go, you would say that, yeah, you take any numbers, this will happen. You multiply x, y, and xz, they're equal, then that means y and z will be equal. But x and x, y, z can be any numbers, right? What if x is equal to 0? What if we have 0 multiplied by 2 and 0 multiplied by 3? The end result is 0, right? So they are equal, but 2 is not equal to 3. So therefore that means that it does not imply y has to be equal to z. X is 0. So you have a counter here. When x is 0, you will have that problem. Therefore, this way implication is false. Hypothesis holds true, but result we're not getting the same. Okay. What about the other way around? Y equals to z. Will that imply xy is equal to xz? Yes. Here you will not face any counter because no matter what number is x, given that y is equal to z, I can pre-post multiply. It's just these are numbers. So I can just multiply x and it's going to be the same thing. It will be equality will hold, right? So what we get from here is that the converse this time is actually true. So that's how these implications are worked out. Many a times you get these kind of questions, you face these kind of questions, or you try to prove certain things which are based on implications. Try to simplify it. Always have your given, always have what you have to prove and simplify the scenario for you. Remember, we are here to simplify our problems in mathematics and not to complicate them. Okay?